Hello everyone, my name's Lou and welcome to our demo 2. So to begin with, I'm going to go over the agenda real quick. So over the past few weeks, we have successfully creating the CI/CD pipeline, and we also set up the AWS EC2 server for the Jenkins to be hosted at, and we'll also be able to send data from the demo application to the Datadog APM by now. And we will also going to discuss some our current sprint plan, the burn down chart, as well as the tasks for the next sprint. So I'm going to do a quick demo for the CI, and before I do that, I want to mention that for the part for our AWS EC2 instance. So to begin with, we successfully set up the Jenkins our remote AWS EC2 instance. We installed all the required dependencies. So for example, Jenkins is written in Java, so you need to make sure that in your environment you have the Java installed, and Dockers and all this other dependency like that. And we also set up the security group for that particular instance. So in that way, people inside our group can access the instance remotely but safely. We also pulled the Docker image and then created a container using the Docker image, and then run Jenkins at the port 8080. So now I'm going to quickly show you the Jenkins main dashboard. So as you can see right now, it is up and running on our AWS EC2, and this is our the dashboard for our Jenkins project, and we created a test project that was written in Golang, and when you goes into this project, you'll see that all the build histories with this, and the way currently it is set up is it is triggered every time the Git repository has been updated. Then the build will be automatically triggered. And yeah, that'll be all from my part, and my teammates will demonstrate more.
Instead of building several jobs for each phase, we can now code the entire workflow and put it all in a single Jenkins file while building the Jenkins pipeline. Now, there are two ways of building this Jenkins pipeline that can be done locally, which is known as declarative pipeline, and it can also be done directly at the Jenkins UI. The only difference between these two is that when we're doing it locally, the syntax starts with a pipeline, whereas when we're doing it at the Jenkins node UI directly, it starts with node. The other basic terms that we need to know while writing the syntax is that the main, that is the agent. The agent basically, it instructs Jenkins to allocate an executor for the builds. This basically means that this can either be null or it could have a value such as Docker. Stage basically defines all the work that needs to be performed, and each stage depicts a specific task that needs to be performed, and steps comes inside the stage, and it basically tells us the order in which the commands need to be executed for a certain stage. These are the basic steps to build a pipeline at the Jenkins UI. The first one would be to just create a new item and select it as pipeline. Then we go to the pipeline section and write the pipeline script node that can be seen here. As you can see, there is node, stage, and this is the command inside the stage. And then after we've saved the pipeline code, we then build the pipeline. As we can see, this is the stage name, and this shows whether it has been a success or a failure. So this is the final plan that we have for our CI/CD pipeline. We are currently at this stage where Jenkins takes the code from our GitHub repository and it builds a Docker image. After this, we have to configure such that this Docker image is pushed to the Docker Hub. And then this latest image is then taken from the Docker Hub and deployed to the Kubernetes cluster.
Hey, this is Vinay. I'll be explaining some of the terms and services we'll be using for this project. OpenTelemetry Collector is a vendor-agnostic separate agent process for collecting and exporting telemetry data emitted by processes. Datadog has an exporter available within the OpenTelemetry Collector to receive traces and metrics data from the OpenTelemetry SDKs and to forward the data onto Datadog. This is the difference between logging and tracing. The purpose of logging is to track error reporting and related data in a centralized way. The goal of tracing is to follow a program's flow and data progression. By tracing through a stack, developers can identify bottlenecks and focus on improving performance. These are the steps to push data from an application to Datadog APM. First, we need to configure the OpenTelemetry collector by adding Datadog exporter to the configuration file along with the Datadog API key. If we are receiving traces from the host, we need to determine which ports to open to the container. And if we are receiving traces from other containers, we need to create a Docker network. On each OpenTelemetry instrumented application, we have to set the resources attributes using the languages SDK. Finally, run the OpenTelemetry collector container and application container to ingest OpenTelemetry traces with the collector.
As you all know that we are using Datadog for the monitoring, troubleshooting and optimizing the application performance, infrastructure, logs and synthetic test, I will be giving demo about the progress we have made in pushing the traces to the Datadog APM. The application that we are looking here is a demo application in which the client constantly sends requests to the demo server. This is a service map which provides an overview of the services, how they interact with each other. So this service map can be used to check whether a service has issues. It will be color coded eventually, but since we are facing a learning curve, we could not implement that. So it will have the service as green if the services are working fine and red otherwise. Let's say our client service is facing issues. We can inspect the service. We get to see the dashboard where we can see charts regarding the request and the error, the latency in terms of percentile as well, that is 50 percentile, 70, 90 and so on. We can also see the errors by version, the percent of the time spent, and this is the latency distribution. Apart from that, we are also able to check the resources. So in the resources we can view the HTTP endpoints. Let's investigate on the execute request HTTP endpoint. We'll see similar data as we saw in the service, that is the request error and the latency in terms of percentile, the latency distribution as well as we get to see the request. So in case if a particular endpoint is failing, we can investigate by clicking on that particular request, and here we can see upon opening the request you get to see the flame graph. So the flame graph helps you to track the request flow in the microservices architecture, and it becomes easier to track which service is failing. Besides that, we can also check the logs, so to get the detailed information, although right now it is not set yet, and we are working to set up that along with the infrastructure metrics. So that is pretty much it about the demo.
So the challenges that we are currently facing are Docker configuration for Jenkins and to determine the correct configuration for OpenTelemetry to send the trace data to Datadog. The goals that we achieved in this sprint are, so we were successfully able to push the trace data from our demo application to the Datadog APM. We got better understanding of Docker and Docker images. We also got better understanding on the steps to configure Jenkins for the CI part. And we also have a skeleton ready for our CI part of the application. So this is the burn down chart. So we had committed for over 40 points this sprint, but we apparently overcommitted and we were able to complete around 28 points in this sprint. Moving on, so the plans that we have for the next sprint are to configure the existing pipeline to include the CD process. We'll also be studying more about Kubernetes to include that in our application. For the Datadog part, So we currently are having the trace data that we are pushing from the demo application to the Datadog APM. But now we'll be replicating the same configuration for our actual social network application. And last but not least, we have to deploy the Datadog agent on localhost and EC2 to push the infrastructure metrics to the Datadog APM. Thanks.